larger shield, much like the Starship Enterprise, called a magnetosphere, which protects us from these highly energetic particles. It redirects them towards the poles, and in so doing, energizes the aurora. Now, this consequence of a cataclysmic explosion in space right on your front porch isn't too shabby. Although it does take hundreds of tons of atmosphere along with it, it's okay, Earth can cope, but they're not all this gentle. In 1859, there was an event so huge, the biggest one ever recorded, in fact, and observed by eye, that it set telegraph poles on fire due to the tremendous induced currents at the ground. Now, when you look up what a telegraph is, what you'll find is that 160 years ago, we did not have a whole lot of technology compared to today. So that we were lucky that that was really the first or the worst of the damage that occurred. If that event had happened today, damages to the US alone could reach into the trillions of dollars. And that's because major US cities are sitting on top of nicely conducted bedrock. A more recent example occurred in 1989 when one of these space storms knocked out power to millions of people for 9 hours in Canada, costing the Canadian economy about $6 billion. $6 billion for 9 hours, and that was 30 years ago. And it's all because of these pesky charged particles that are moving at tremendous speeds towards the Earth. They can disrupt GPS, fry electronics, blow transformers, interfere with satellite communications, and that's just to name a few. And it's only going to get worse as we become more and more dependent on space technology, right? So no power, no internet, no social media, no GPS for planes near the poles. It's hard to pick out which one's worse. Now, I don't know about you, but when I'm flying to Japan for work, I find a degree of comfort in knowing that the pilots are not using the stars to navigate by. So I'm going to choose that one. And if we cannot protect equipment and humans, yes, that's me, and humans on the moon or on the way to and at Mars, then we may as well forget about deep space travel. In fact, there was an event that occurred in 1972 between 2 Apollo missions that could have killed all of the astronauts on the moon's surface in a fairly horrific way through radiation poisoning, even in their spacesuits. Now remember what I said about possibly going back to the moon during the next solar maximum? Does that get your attention? Yeah, I hope so. By the way, NASA, if you're listening, I still totally go. I have my David Bowie playlist already picked out. Ready. Now, as bad as all that sounds, we're only mostly helpless. There are groups or agencies across the globe that are working fairly tirelessly at trying to improve space weather predictions so that satellite industries and other industries can be prepared. As just one example, a NASA-led probe named Parker was just hurled towards the sun this past summer. I was lucky enough to be at the launch. It was incredible. And it was sent out there to help us understand how the sun's wind connects the entire solar system, and also how the sun's temperature, the atmosphere, is heated to temperatures that seem to defy physics. This is something that's been keeping us going for decades now. And on its way, on its journey, Parker will become the closest man-made object to a star ever. So, if Earth was out at Los Angeles and the sun was here in Nashville, Parker will get closer to Memphis. The closest we've ever been was somewhere out in Kansas past Wichita. Have you ever made that drive? Oh, it is so long. But you can go to Memphis for lunch at Corky's and be back in Nashville in time for dinner and a hockey game. Go Sabres. Please let me leave peacefully. And there are many other groups across the country and across the globe that are working to find new ways of looking at the sun to fill in the missing pieces, because there are still many, like the group that I'm part of in Huntsville at Marshall Space Flight Center, where we develop instrumentation for testing on sounding rockets and on the International Space Station and on spacecraft. This one is going to launch again in less than a month, actually. This is an exciting time for solar physics. We're in this sweet spot where technology is finally starting to catch up to our questions. And I encourage students and your kids, come join us. This is a spectacular job, right? And you don't even have to be a scientist to do this. So please ask me how to get involved. There's a lot of job satisfaction that goes along with, I don't know, protecting the planet, enabling space flight. I feel like a superhero sometimes. Now, Elida, who is now in college, and where they listen to a lot of TED Talks, and she's one of my 4 favorite children. She's not my favorite. Wherever she is, she's out there. She put together a little presentation for me when she heard that I was doing this, because she was super excited, right? And it was titled Hot Knowledge, and it had lots of cool graphics in it, because that's what you learn in high school and college now. And here is her updated list of sun facts. And she has grown quite a bit over the past decade, and so has her understanding of our relationship with the sun, as I hope yours has as well in the past 15 minutes. The sun isn't just a big light bulb in the sky. It is where science fiction meets our reality. It is the best laboratory to the universe that we have, and it is just right there. It gives us a reason to look up every day and to work together for a very common cause, human survival and progress and all. And above all that, it is beautiful, and it's terrifying, and it touches us all. Thank you.
Dr. Sabrina Savage, fabulous.